Good afternoon, good morning, good night, good evening, depending on when you're watching the video. Today we are going to work through slide 31 of lecture set 2. So at this point, we should be fairly familiar with the different distributional shapes. On this particular slide, we're going to focus on the unimodal shapes. So symmetric, left-skewed, right-skewed. In addition, we should be familiar with the measures of center. So the mean, the median, and the mode. And on this slide, we're going to focus on the mean and the median and the relationship between the two when we are working with right-skewed, left-skewed, or symmetric unimodal distributions. Okay. Now, the purpose of this slide is to illustrate when you can expect each measure of center to truly be at the center of the distribution. And the common theme that you will observe through these illustrations is that the median is the only value that is ever, is the only value that is consistently at the center. All right, so we'll start off with our symmetric unimodal shape. Okay, so this is our symmetric unimodal shape. Okay, so the peak is at the center, or the mode is at the center. When we are working with distributions that are symmetric, the mean will also be located at the center, and the median will also be located at the center. All right, so only in the situation that a distribution is symmetric will the mean actually be at the center of that distribution. As such, the mean is the measurement that is most typically used when we have a symmetric distribution. As is mentioned on the slide, the mean is influenced by outlying points. And as we defined in the lecture set, we call the median a resistant measure. And in that sense, we mean resistant to skewness. So if we have a right-skewed distribution, okay, something like this, the median will still be at the center, but the mean is going to get pulled in the direction of skewness. So in the case of a right-skewed distribution, the median remains at the center, but the mean gets pulled with the skewed tail. So when a distribution is right-skewed, okay, the mean will always be bigger than the median. All right. And in short form notation, we would write mean is greater than the median. Okay. So this inequality symbol here is saying we are eating the mean. So that means that the mean is bigger than the median. So this is a short form notation for what is written above. In the case of a left-skewed distribution, we have the opposite effect. So if we have a distribution that's skewed left, so something like this, for example, again, the median will be at the center, but the mean is going to get pulled with that skewed tail, just like it did in the first example. But now the mean is getting pulled to the left, so on the negative side. So in this situation, the mean is going to be less than the median. So we can write here, the mean is less than the median. All right. Okay, so in summary, for our three main distributional shapes, the unimodal symmetric, the unimodal right skew, and the unimodal left skew, only in the case of symmetry is the mean actually at the center. So therefore, the mean is a preferred measure of center when the distribution is symmetric. When the distributions are skewed, the mean gets pulled in the direction of the skewed tail. So in these situations, the median is the preferred measure of center because the mean is no longer at the center of the distribution. Okay, as always, if you have any questions, please let me know.